Now there is one experiment which has been discussed for measuring as an example of measuring very small lengths, and that particular experiment is oleic acid experiment. And what are we trying to do in this oleic acid experiment? We are trying to measure the length of this oleic acid molecule. So that's the intention. Okay, so of course we cannot measure the length so accurately, so we would only be trying to measure this particular length. So, see, the thing is that this experiment, although it has been discussed, the process is often not very clear just by reading the text what actually was done in the experiment, and that's why we have put here so many assortment of pictures here, which to if when we go on you will understand what it actually means. They might just seem like some random pictures for now, but the idea is this. Okay, so let's first understand what the experiment is. Okay, see, the objective is very clear. We want to measure this length L of the oleic acid molecule, and of course we will be only measuring it approximately. Okay, so that is the first thing, that is the objective. The second thing is how do we actually proceed with the experiment. Okay, so the experiment goes like this. So first we take a certain amount of oleic acid. It is already known what amount we take, and then we dilute it. So we mix it with what? Alcohol. Okay, so we mix it with alcohol. So I have taken this oleic acid and then oleic acid, okay, and then I have added to it alcohol. Okay, so I have diluted it. The dilution process is such that we do it 2 times. So first I dilute it, then I take the diluted solution and again dilute it with even more alcohol. Okay, so the solution that we have finally is very dilute oleic acid. So that is the first thing that we have done here. Then what do we do is that we prepare, so that is the oleic acid preparation. We have prepared a diluted solution of oleic acid with alcohol. That is the first thing that we have done. Okay, so solution is there. Now the second thing we do after that is that we take a tray. Okay, and in that tray we put water, we pour water. Okay, not it doesn't have to be too high, but the tray has to be very large. The surface area has to be large, although the quantity of water might actually be small. In that tray, what I have done is that I have sprayed. Okay, so I have randomly sprayed. I could spray anything. Okay, so in the book it gives Lycopodium powder. So Lycopodium powder, what it is? Those are just spores. That is it. They are spores of a kind of a plant. Okay, so they are spores, but the thing is that they are numerous. Okay, so the plant is very prolific. It generates lot of spores. So that is the thing here, and that spores are very kind of, they are very powdery. Okay, and that powder I am sprinkling on top of this water. So there is a fine layer of that powder created, but that powder could be anything. It could be your normal talcum powder. Okay, that could be your if you like spicy food, then you can also spray the spices, right? The finely powdered chili powder, for example, you might spray that as well. So that powder could be anything, or that could be talcum powder, like I said, or sawdust even. Okay, but here they have used Lycopodium powder. The main objective of Lycopodium powder, we will see, is that what happens is that after we have sprayed the Lycopodium powder, we actually add just a few drops, a known number of drops. Okay, so let's say n drops of oleic acid here. Okay, so we have put in oleic acid right here at the center. Okay, so previously this entire surface was covered with let's say Lycopodium powder, and after as soon as I put that solution, okay, the diluted, very diluted solution of oleic acid, known number of drops. Okay, and we know not only the number of drops, we also know the drop of each volume, how much it is. Okay, I know that, and I pour in here. So then as soon as I do that, what would happen is that the alcohol will actually evaporate. The alcohol evaporates, and the oleic acid, it forms a fine layer over the water, and in that process it just displaces the powder, the Lycopodium powder that we have sprinkled on top of this water, right? So as the oleic acid is expanding on the surface of the water, it actually displaces the Lycopodium powder, and that is the purpose of powder. The powder we are adding only so that we can measure this area. Okay, so this area we then measure and we call it A. Subsequently, we will see the calculations how they work out. But the entire objective is that we are measuring this area. So this area we are able to measure, and so that we will not be able to see oleic acid. So how do we measure this area? How do we know that this is the area till which the oleic acid has actually spread? We know it by spraying the lycopodium powder beforehand, so that when the oleic acid spreads, it displaces the lycopodium powder, and then eventually I would be able to measure this area. Now what happens here is that this oleic acid, it has two ends. So this is one end, this is the second end. Here these white balls are actually hydrogen. The black thing here is the carbon chain. Okay, the red here is actually oxygen. So this oxygen, hydrogen, and the oxygen here, this is COOH. This area of oleic acid, okay, this region, okay, on one side, okay, this is polar. What do we mean by polar? Polar means that there can be some charge separation which might happen here, and because of which this end might actually take on some charge. Now water molecules we know are actually polar. They are slightly polar, not very much polar. Okay, so slightly polar, and what happens here is that this end is slightly negative and this end is slightly positive. Okay, so water molecules are actually polar. So there is charge separation which can happen here. This thing can become polar, this thing can become polar, and then they will eventually attract each other. So one end of this oleic acid molecule is actually what we say hydrophilic. It loves water. Philic means love. Okay, it likes water, so it will always get attracted towards the water. So as soon as alcohol evaporates, the oleic acid comes in direct contact with water. One end of the oleic acid would actually just go and get attracted to water, and oleic acid molecules, they will turn. Okay, they will turn and they will arrange in such a way that the polar end is actually below. Okay, so this is in touch with water, and they will be standing like this. Okay, and if there were any oleic acid molecules, for example, if there was an oleic acid molecule right here, then what will happen? Slowly and gradually it will also get attracted to water, and then it will also sort of fall down and then get attracted and become vertical. So what would happen eventually, as the alcohol it evaporates, all the oleic acid molecules, they will line up. Okay, on standing all vertically, they will line up on the surface of the water, and we will use this particular arrangement of oleic acid, this particular property of oleic acid, that one end is actually hydrophilic, the other end is actually hydrophobic. Phobic means it is afraid of water. So because of that, there is a orientation. When as soon as it comes in contact with water, there is a particular orientation which this oleic acid molecule it prefers, and we will use that property. And because of that property, they will all arrange vertically. They will all arrange themselves vertically as the alcohol evaporates. So there is a role of all the things here, and with that vertical arrangement, I know that oleic acid molecules are now arranged here all vertically, and if I measure this thickness T using whatever mechanism, I am actually able to measure the thickness of this oleic acid length of this oleic acid molecule. And mind you, because of that attraction, there will be only the oleic acid molecule will prefer to be in touch with water, and hence they will try to form a single layer of molecules. All of those properties are important, and when I am measuring this height of this film thickness T, I end up measuring the length of this oleic acid molecule. So we can say that T is equal to L, and of course this is not an exact measurement, so it is approximately equal to the length of the oleic acid molecule, and that is the principle behind this entire experiment. And now let us understand the maths, how actually we went about doing this experiment. Okay, so in the book what has been written is that we take 1 centimeter cube of oleic acid, but we dilute it twice. So finally what happens is that first we dilute it with in such a way that I make this 1 centimeter cube to be 20 centimeter cube. I add alcohol to it, and then I take this 1 centimeter. So from this 20 centimeter cube, I again take 1 centimeter cube and I create a 20 centimeter cube solution again diluting it with alcohol. So in the final solution, right, if I take, let's say, 1 centimeter cube of final solution, that is what I am taking. I am taking 1 centimeter cube of final solution. What would be my amount of oleic acid? See, alcohol would eventually evaporate, so we are not really concerned about that. We are only concerned about the oleic acid, because that is the molecule length you are interested in. That of course will be 1 by 20 into 20 centimeter cube. Right? That much we can appreciate, that in 1 centimeter cube of my solution, so this is my solution, and there will be this much amount of oleic acid. Okay, so this much we can understand. The other thing that we have to know is that I am adding n drops. Okay, so this is experimentally n drops. Each drop has a volume of V. That is also experimentally determined. When I am trying to add a drop, I have to understand, right, using a pipette or using whatever, using a dropper, whatever measure you use, whatever thing you use for measuring, you can do whatever. But the thing is, you have to know, right? Eye drops also, when we drop it, we know how much quantity is going in one drop. Okay, so we know how many drops we take. Okay, so for eye drops also, you go to a doctor will say take 2 drops. So we know how many drops of oleic acid we have dropped inside that bucket of water, and we also know what is the volume of each drop. Okay, so this is the volume of one drop, note that. And we know that in 1 centimeter cube, okay, so this is the volume in centimeter cube. Okay, again understood. In 1 centimeter cube of solution, this much oleic acid is there. So the total volume of oleic acid that I have dropped is this much. So how much oleic acid would be there? It will be, I just have to multiply it by this number. Okay. So this is the final volume of oleic acid that I have dropped inside that bucket. So this is the final volume. That much I know. On one side we have the volume of the oleic acid that has been dropped. Now on the other side also we have to find the volume of the oleic acid. So how do I find that? After the experiment is done, I measure this area A again in centimeter cube. Okay, but I don't really know the thickness, so I will write it as T centimeter for now. Okay, and we'll understand how the maths would give us the thickness. So this area A I know. Again we have measured the area in centimeter squared. Okay, and then I also have the thickness T, which I don't really know at this point, which is, we assume that it is in T centimeter. Some amount of centimeter would be there, which we have not. We cannot really measure the thickness. The ultimate objective of this experiment is to come up with that thickness of the layer of oleic acid, and ultimately at the same time we come up with the length of a oleic acid molecule. So now I know everything on this side. If you think about it, I know everything on this side. Okay, and the dimensions here are actually centimeter cube. So I can then finally write T is equal to, okay, so these two quantities have to be equal, because this is the volume of oleic acid. In the experiment also, this is the volume. This entire thing is actually the volume of the oleic acid. So this is also oleic acid volume. So so this is also the volume of oleic acid. Here also we have the volume of oleic acid. This is the volume that we have dropped, and this is the volume that it is after the spreading has happened. Both of those two have to be equal. Alcohol is already gone. Okay, so now these two, when we equate, we can then come up with the T in centimeter, and that comes out to be NVD. Okay, so that is the volume of one drop multiplied by 1 by 20 into 20. Okay, and then of course here we have at the bottom area. This area we have measured it in centimeter squared. I already told you that. Okay, and this thing that we have measured was in centimeter cube. Okay, so centimeter square and cube, they cancel, and the final thing that comes out here, okay, is actually in centimeter. Okay, that makes sense, because the thickness of this layer has to be in centimeters, and this thickness is actually equal to the length of the oleic acid molecule, right? So here we have just devised a method of computing very small lengths. Even the length of a molecule we are able to compute indirectly. It's such ingenious experiment, right? Think about it. And we have used several properties. We have used the property of oleic acid, we have used the property of the alcohol, and of course we have used the property of the sawdust or the lycopodium powder, if you will, that it floats around the water and it can be easily displaced. Okay, so we have used all of those properties and they are actually important. Hopefully it is now clear. We will continue more about measuring of length. So this is the measuring of a small length in a separate class. Thank you.